Welcome everyone, and we are happy to have you in this new webinar. So I'll let the floor to Sabrinas.
Hello and very welcome to PHARMECO webinar number 6, entitled Standardized Green Value Engineering Approach to Enhance Sustainability of CAPEX Projects within Pharma Industries. I will be a moderator of the webinar. So my name is Šarūnas Petronis. I'm working at Rice Research Institute of Sweden. And in PHARMECO, I'm co-leading work package 5, entitled Sustainable Decontamination. Traditionally, sterilization in place and cleaning in place processes require lots of energy for steam generation, lots of high quality water for rinsing steps. So there is a lot of potential for optimization and new technologies to make the contamination greener and more sustainable. But how to get those technologies implemented in working pharma plants? You will hear about that from Dr. Alessandro Rosengard, who is today's speaker. He's a subject matter expert in process sustainability and green engineering at VTU Engineering Company. And his presentation will take about 45 minutes, and we will have about 10 minutes for questions afterwards. And please kindly write down your questions in the chat section at any time during the presentation so we can collect them and read loud after the presentation. So Alessandro, the stage is yours.
Okay, thank you very much for the introduction. So as Šarūnas said, I'm a subject matter expert. That is a quite generic word to express an even more generic term that is a sustainable process design. And I will a little bit introduce what I'm doing actually. So by career, I'm a process engineer, a chemical engineer, and I did a PhD in sustainable process design. So I had a specific focus on how to change traditional oil and gas production into something that is bio-based or in general sustainable. To do so, I got acquainted with the green chemistry and green engineering principles. And when I moved into VTU engineering with an EPCM contractor, so we design plants in different fields. So we have experience in chemical industry, pharmaceutical industry, food industry, all together contribute with their specific standards and technologies to a well-defined level of quality, but also cost control. And in this, we add on some skills of project management that together, mixing, created this sustainable approach to process design. I will show how this works with some specific case studies, and the focus will be specifically on pharmaceutical industry. So in the first part, we will understand why it is important to talk about green engineering in pharma plants. And right after, I will show the methodology that allows to change the things in existing plants in situation in which the quality as a set type of process, the technology is very well defined, everything is regulated, but still there is a space for making production greener. And with greener, the question is right, will we get copies of slide? Yes, if you will after, but the point is the results is how to implement this change in a real way, in something that you can measure and you can gain in the end of the year with some clear savings. And I will show you also a very practical example of application. So there will be some project management, some technical topics, and to be less heavy as an engineer speaking about processes, I wanted to introduce the topic with a quiz. So you see here, this is a a question that I like to ask to see if people are familiar with concept of sustainability and impact, because it's not very easy to understand if something is impactful or less impactful. So with an example on the common knowledge of everybody, I will show you the impact of things, of how they are measured. So you see, one of the most established and also easy to understand metrics for environmental impact is the equivalent tons of CO2 emission per year or per unit of a specific product. And this is a good reference, and it is also very well linked to the global warming potential, or the climate change effects that this introduces. So just to have a reference of how much is the common measure brick, that is the ton of CO2 equivalent, we have here a very familiar example. So the family car that is used for family tasks like grocery or taking kids at school, with that power has an impact of 90 grams of CO2 per kilometer. And considering the average utilization of this kind of car per year, you will have more or less 1.2 tons per year. You see that Audi RS6 car for the same amount of kilometers will cause the triple emission in a year. So it's it's much more impacting. But then I wanted to ask you, and you can write down in the chat what is your opinion on this. Which motor would cause some 6 tons of CO2 per year in the normal utilization? It's just to give you a reference. The first is a small Fiat 500 gasoline. The second is still gasoline, but it's an Audi RS6, so a very different car. What do you think is the third? Somebody told me the Tesla. Other people mentioned once, yeah, it can be a SUV. That sounds good. Uh, SUV is probably maybe a Dodge, maybe a Hummer, the big Hummer, or the one. Well, this is a tricky question. In reality, this huge consumption that is higher than a car, it's a very small process pump that is used. It's everywhere in any network for air conditioning, for running around in the plant, the water. It's a small plant. It's a pump. It's a 2 kilowatt, and you say, okay, it's electrical driven pump. Yes, but electricity, is produced with an energy mix. Is not only sustainable sources, but there will be also part of non-renewable, like gas or carbon coal, for example. And with that energy mix, so that amount of emission per kilowatt hour, this is the impact. The meaning of this is that engineering and plant design plays a huge role when building a new facility or revamping an old pharmaceutical facility. And so thinking from the very beginning how to make production the safest, the greenest possible, has a real impact, has a real consequence. So for us, it's a matter of responsibility for us who design the plants. So focusing on, industry means everything. So we need to focus a little bit on a specific sector. So I wanted to talk about pharmaceutical industry. And data are becoming available only recently. Have been becoming available only recently because in the past, before the growth of sensitivity in environmental topics, it was a matter of cost. But if energy is cheap, then there is not an issue on that point, and it was not even available any information on how much is too much impact or less. So I started from a collection of data that came from the implementation of the standard ISO 15001, that is the energy management system for a large energy consumer. And I'm focusing on secondary pharma plant because it's more homogeneous, because there are so many production that force us to find something that is pretty standard, pretty common, to have a valuable comparison. And in this case, we work on the secondary pharma because it's the biggest consumption and the biggest impacts are typically related to the air conditioning issue. So there are large areas of production that need to be classified. So there is a very demanding HVAC system that guarantees a specific pressure, specific temperatures as per the GMP requirements. So there have been some data since let's say 10 years, and there have been some averages that tell us which is a reference number. So we have as an average value that the consumption in terms of electricity for cooling is about 2 megawatt per square, 2 megawatt hour yearly per square meter. Similarly for the heating. The uncertainty level, as you can see, is very, very broad. It means that is plus minus 70% on this average value because the uh, the variability of production and the shape of the plants and the age, the design of the different facilities is very wide, and so these numbers should have a span. What I collected here are some data that I took out from some projects of VTU engineering, just to show that in a larger plant for 20,000 square meters of classified area to a very smaller one of 2,500, we have some values that somehow are within this range. So it's typically 2, 2.8, 3.5, 3.3, 2.3. So there is quite a big span. To understand how much in a common sense this means that the larger facility, it's consuming like a village of 7,200 people. The middle one is 3,000 and the smaller one is 1,500, because there is more than a linear scalability on this kind of facility. So the question finally is this much? Is this a lot of energy? It is. It is a lot of energy, but at the same time, there is a good news, good piece of news, because this is in the largest cases, largest number of cases, a number that we can improve. Why? Because the plants were designed typically more than 30 years ago with technologies of 30, 40 years ago, because there is always the shift of the standardization in industry that somehow picks the technologies of the decades before. So today we can improve these numbers, we can work everywhere. The point is why it is difficult to have this improvement, and this is because industry and in general every capex project has some very thick boundaries that are very popular among project managers. This is the so-called trade-off triangle, or even the iron triangle. So every project has typically a constraint in terms of time, budget, and scope, and there are some aspects that cannot be negotiated, that are quality and safety. So in the end, if you push on time and budget, probably you will reduce the scope, and vice versa. If you have much scope and a good, and you need to keep the budget on a control, then time tends to delay it. Well, now we are adding another variable, that is sustainability. And sustainability in this case erodes the margin for the other parameters. So in this moment, sustainability is seen very often as a competitive driver. So it can jeopardize what scope, time, and budget are trying to keep under control. So it is needed a method, something systematic that helps to guarantee the most important aspects for industry that are typically cost control and time to market, especially in pharmaceutical plants. And we need to treat sustainability not as a foggy generic word, but something really measurable. We need the KPIs to measure it, and also we need to understand the right moment in the project to implement sustainability. So in general, there is not a universal solution. So we cannot say, oh, everybody, let's go with green electricity, or let's recycle or whatever, because every plant has its own history. So the idea is to deep dive in the real field, in the operation, and understand where are some the levers, the helps that somehow can change the things. In fact, plants are never a beautiful green field situation where you can design as per the best available technologies. But you start from something existing, something that maybe has been defined or evolved in time with a lot of compromises. There is the need of keeping cost control and production always active, and this is a priority. And also the technical offices, so the people who know the plants are very reduced. There's always less people knowing the plant, knowing operation, and they're always super busy, and very often the starting point is not even very clear. So I say that only since 10 years, more or less, we have sufficient data on energy consumption. Imagine how more difficult can be for waste management, for water control, consumption, and all the other aspects that contribute to the concept of sustainability. So the road to sustainable business is not very straightforward, but in this context that we can tell it is quite complicated, we came up with a solution that first of all must be easy to implement and to understand. So what we did was to start from a very known and also popular methodology to improve plants. The, the, the method is standardized, is the ASTM E169914, that is the value engineering method for cost enhancement. So it means it is the typical situation in which we are at the end of a feasibility study. We came up with a budget, so the total cost of investment for a specific project, and then the management say no, we need to reduce the budget. There is too much, and so to systematize this approach to cost enhancement. Originally in the Air Force field, so it was Boeing, if I am not wrong, in the 60s, who developed a standard methodology to analyze the project and reduce the, the cost, the contribution to the final cost. What we did was to start from this established methodology and add some other tools in order to reduce both costs and sustainability indicators. Sustainability indicators means, for example, the global warming potential, so the equivalent CO2 emissions, or the water consumption or the waste production. Any index can be applied in this context, and we use a similar stepwise approach to find solution that need to be implemented in a second moment. So in this way, we can perform a systematic analysis of the status quo, of the situation, of the current situation, and find a way to make it more sustainable in the boundaries of what is feasible and what is good for the project itself. So without many other introduction, I will go directly into this methodology to show a double possibility of application. So we have called this a green value engineering method, and it is applied on engineering projects. So we do not have yet the whole facility, We have only engineering documentation that can be the process schemes, can be the layouts or the basis of design, the user requirement can be even the sole document that we have at the time. And the same method can be, with some adaptation, used on existing facilities. So fully operating plants that at a certain point need to be upgraded or revamped. So the idea is to get, for the next stage of the project development, a more sustainable design, or in the case of sustainability strategy and implementation application, we have a short mid-term, so typically in the span of the next 5 years, list of implementation that will reduce the target parameters. So let's go step after step to see what we typically do. So the first point is obviously the definition of a baseline. So we need to improve the plant, so we need to understand which is the starting point. For the case of the engineering uh, declination, so we have only the project, we started from a basis of design or the available engineering documentation, possibly some technologies or quotation that we have available, and the targets from the client, the company, that can be CAPEX targets, because we are focusing also on the value of the future plans, and the sustainability targets. So they can be the ESG targets on a global corporate area, or can be some specific needs of the single facility. We have had this case, for example, in an area that out of a sudden was suffering some drought issues during the summer. So water became important. So we needed to redesign to save water with respect to the original basis of design. In existing plants, instead, we can start from a site survey, or if there are the historical design documentation or some tracking of the energy and mass fluxes, we collect all this information and we include also the sustainability or economic targets that can be, as I said, very different from each other, and there can be more than one. The target can be energy reduction, can be water consumption reduction, or emission reduction in terms of wastewater, but also waste solvent, solid waste, anything that goes into the process. If we have the possibility to focus on the process as a process engineering company, we can definitely go into it. So once we have a clear overview of the starting point and the expected target that we need to aim for, there is the most creative part of the project, that is the improvement in identification, that is based, as per the original standard, on a brainstorming, actually a guided brainstorming session, in which we make use of interdisciplinary and interdepartment teams. Interdisciplinary because the solution are very often the combination of a synergy between different fields. So we want process engineers, electrical engineers, HVAC experts, energy managers, everybody can, also quality, can contribute with their perspective on the problem and propose smart, non-obvious opportunities for improvement. But at the same time, we like to work with interdepartmental teams, especially on the client side, because all these stakeholders can contribute. And I mean, very often the maintenance people can have the deepest insights on the constraints or the pains, let's say, of the plant. And so the maintenance manager can come up with some of the most effective solution, but also at the same time, quality control can add some precious ideas to improve, for example, the washing processes or the sanitization steps. So on this part, everybody is welcomed, and this brainstorming uses the so-called value improvement practices that are some checklist that are very useful to make it more systematic, to make the analysis more systematic, challenging different aspects in terms, for example, of harmonization. Harmonization means probably the engineering follows a standard, and this standard may be too rigid or too weak for the specific application. An example is to use stainless steel pipework for some waste stream that is maybe not so important for the process. So the standard forces you to use stainless steel, but plastic could be enough. So we challenge that requirement, and if it is actually too much, then we can relax the constraint and save money in this case, but also we can apply the same idea to the green KPIs. So it can be reduction of energy and resources, reduction of construction materials. This applies for the project review, or the reduction of the amount of chemicals or waste that are involved. So these parameters are perfectly matching, and we can use the same checklist for any of the possible targets. And after this creative session, we collect dozens, I would say 50 or 100 possibilities, opportunities of improvement for each case. But the point is, now we need to talk numbers, to associate to these ideas some measurable KPIs that allows us to create a ranking, or and to use a Pareto approach to have the maximum effect with lowest effort. So we use both quantitative and qualitative parameters in this evaluation session. And in particular, we use for the sustainable. So for the economic part, we have the most common economic indicators that are the CAPEX, capital investment funds, let's say. So the CAPEX, or the operating expenditures, the OPEX, or the total cost of ownership of the specific equipment, or the modification on the field of sustainability. Instead, we have other indicators that are agreed in advance with our interface. That can be the global warming potential, the water use, and so on. To have referenced numbers on these aspects, we exploit the databases of EcoInvent that are available for any life cycle assessment tool, for example, CIMAPro, and we take these values not in the context of an actual life cycle assessment, because uh, typically LCA are used for product, and in this case, instead, we are focusing on the process. So it is not the same field of application of the so-called ISO 14001 standard. But what we look for is a benchmark. So the possibility to say that option one allows less impacts than option B, and we can rank these options. Then the life cycle assessment can come in a future moment, especially for new plants. You need the whole plant and the measurement on the operating one to have an actual life cycle assessment. So altogether, we collect this data and we associate a score that allows us to identify from a green perspective which is worse, which is neutral, which is actually improving, from an economic potential, which is in this case, as an example, we only condensated with a payback figure, which has the shorter payback, so it is better for improvement from an economic point of view. And also, since we are in the framework of a project that has a very defined time span, we focus also in the maturity of the design, if it is quick to implement or it needs some specific development. Step 3 allows us to see all the options in a ranking, but if there is much uncertainty in the starting data, or we are talking about uncertainty in the environment, so for example, the economic conditions, for example, make or buy for electricity or thermal power or the opportunity to use sustainable electricity that is typically more expensive than oil and gas based electricity, uh, we can have a very, very broad change of these values that are our basis of design. So to overcome this uncertainty, we have two approaches. The simple one, the quick one, that is the sensitivity analysis. So we analyze the KPIs that we have measured before against some changes in the main starting variables. Or if the situation is even more complicated and we apply this just before the beginning of the war in Ukraine, where energy values were completely out of control, in that case, we can use also Monte Carlo simulation to provide even a confidence interval on a specific threshold in which the opportunity is worth to be implemented, or it is better to postpone or to delay the investment. Finally, we have a good collection of opportunities. We have their impact. We can say which is worth to be implemented. This is negotiated and discussed with the stakeholders of the project. And then we have the need of implementing it. So for the implementation, we can design a plan in more years in order to reduce at the maximum the risk of implementation. So typically in the pharmaceutical company, this is a process of decision making that we want to be the most sound, lean, and robust possible, giving all the numbers that are needed to by the specific stakeholders. So as you can see, it's a cycle that starts from the current plan design and goes in across the brainstorming session. We have all the proposals, and after the proposal, we do this techno-economic sustainability feasibility study. After all the KPIs, we have a session that for us is absolutely important because there is this shared approval challenge, let's say. So we challenge with all the people that are somehow affected by any change in the facility in the plant that is called to give a contribution to point out the SWOT analysis, strength, weakness, opportunities, and threats in order to have the most complete view of the issue and the solution. And if everybody is agreeing on that, because it has been here, they have been involved from the very beginning in the decision-making process, then the implementation is, let's say, straightforward. Not always, but at least it's very easy to see when and how the things will happen. And finally, we have really implemented from the bottom what the sustainable production requires. So very often when I speak about this methodology, I see skeptical approaches because they say, oh, well, it is too complicated. We tried to implement that, but everything was greenwashing. So the risk is always greenwashing. So to have a very strongly sponsored campaign that ends up in no results at all. Well, the approach that I have been implemented is the opposite. So we start from the bottom, knowing a target, and we go in the direction of what actually is the success keys for seeing the things implemented. So to have the green improvement implemented, well, first of all, it needs to be effective. We need to know from the beginning if the idea is, let's say, greenwashing, or it is something that has an impact. So the first thing that we want to understand is the KPIs, the measurable KPIs that allow us to say this is effective. So somebody can tell, oh, let's put solar panels everywhere. Maybe it's less than 0.5% of the entire energy bill, and it's a really, really small drop in the ocean when possibly maybe understanding better or optimizing the energy consumption will have a great effect without a real investment. Also, the idea of this green improvement must be a shared value. Everybody must understand that they are taking action in the direction of a more sustainable production, and this is achieved by engaging the stakeholders. Also, the things need to be implementable. So very often there are great ideas and then production says, no guys, we cannot stop the plant until next Christmas. Whatever you have in mind cannot be done. Well, bottom-up design covers also this part. So whatever we propose is proved. We can for sure implement it. Also, there is the point of the business advantage. Something that is against economics is against industry itself. So every opportunity comes with a payback and let's say cost opportunity analysis. Finally, but not finally for the importance, all the introduction, all the green improvement ideas that we add in a facility is not only driven by cost or the generic ESG targets that sounds only sustainability driven aspect. The most of the improvement that we have in this field contribute strongly in building a more resilient facility. What does resilient mean? So we have seen that in the last year I would say, uh, sustainability has become, let's say, less important. There was the phrase "drill, baby, drill" in the January 2025, and out of a sudden there was no hype anymore in sustainability. But at the same time, economy started to have big fluctuations, and the industry itself had to face energy price that was out of control, availability of good material resources become a challenge. So if we understand the green indicators of a plant and we reduce the number of the amount of resources that the plant needs to run, then automatically the plant is more green, but at the same time is more strong against changes in the economic situation outside. So less dependency on the external world and more efficiency in the way the plant works is automatically a more safe business and a more sustainable in the terms of durable plan. So all these projects come with a long-term vision that do not follow a trend or the request of a CDA, but is based on a long-term thinking that allows the plant to withstand with more strength against the changes in the world. So everything happens, but still we are able to guarantee business continuity, regulatory compliance, and also the time to market, because we are not challenging the industry itself, but we are trying to help it. So this is the theory, and I have spoken a lot. In the last 5 minutes available, I wanted to show you a very practical example that maybe is also familiar with your practice in the past. So what you see here is a network for a thermal center for producing chilled water for the HVAC system of a secondary pharma plant. As you can see, there are 1, 2, 3, 4, 5, 6 different cold producers in the primary circuit and a number of different buildings on the secondary circuit. Why so many different sources of cold? We have a 3-generation plant for 0.8 megawatt, a air chiller that is in one side of the plant, then 2 water-cooled chillers for a total of 3 megawatt, and then other air-driven chillers. Why this? Because it has been enhanced time after time. So it's more than 40 years old of evolution of the plant. And so every time they were adding a new building or increasing production and so on, they try to enhance the cooling production facility, but at the same time there were some constraints that came up with a very inefficient and, let's say, unoptimal plant. Still maintaining production, maintaining the business, so we cannot complain against the engineers that designed this plant. The point is that nowadays, for some 1.2 thousand cubic meters per hour of the whole circle of water and 7.2 megawatt of thermal peak capacity, we have a plant that is super expensive, and also it is not very resilient on a perspective of operability. So there is this issue. Also, they have a huge bill, electrical bill at the end of the year, and at the same time, there is the point that provided that they have a cogeneration plant, and so they burn natural gas to produce electricity, this thermal center has a huge contribution on the overall CO2 production of the facility. So starting from this point, we challenged the design and we asked around how the plant was implemented. And we came up, I will jump all the points until the very end. So the ones that were decided to be implemented. So the first intervention was to predict the weather. So the idea was during the summer, this is in the south of Italy, the plant, there is there is a very hot weather with more than 40 degrees C on during the day. And so they need to power up all the plants to have enough cold power for keeping the facility awake. And the point is, these are huge chillers and they have a long ramp of startup. So the approach is, okay, for the whole month of August, like let's keep everything on and let's possibly work outside of the set point just to have the plant operating and available. Well, having a little bit of control system basing on a meteor station that allows us to understand when there is the peak of heat from the weather and understanding where there is the peak of the need of the cold, monitoring the plant, we together optimize the pattern of operation of the chillers, and we have them on demand, but still saving the 100% availability of before. And this is some 108 tons of CO2 per year and the huge amount of 442,000 kilowatt hour per year. Other thing that we could improve was to understand how the water was distributed on the secondary loop. The approach was let's keep all the pump at the maximum speed always. This means that when the need of water was less, there was simply a circle of waste of energy of these pumps that are 100 kilowatt of installed power, always working at the maximum. There was some inverter, so we added a control system that allows us to reduce the speed of the pump following the need. Finally, all the areas needed to be classified according to the specification. Well, there is the possibility to use the attenuation of the HVAC. This means that we do not lose the class. We allow for the fans to reduce the air exchange in the case there is nobody in the production area and the plant is shut off. And this again contributed with some 31 tons of CO2 per year. In general, to implement all these activities, we had some €500,000 investment, but saving also on the bills, we would have a payback of less than 3 years. That is more than acceptable for any facility, and the total CO2 reduction was minus 174, and this was really achievable. Then, not even discussing on the possibility or opportunity to move to green electricity. that could be another option, but that was a little bit subject to the economic evaluations related to the cost of sustainable sources electricity. So from this perspective, you see that starting from the plant, analyzing the plant and providing some tailorized solution, we can achieve a real tangible, realistic and concrete result without jeopardizing or changing a facility that has been working for 30 years and we hope will keep working for the next 30. This is the theory. This is also an example. If you have questions or any curiosity on the methodology, I'm happy to answer all your questions. You can write directly in the chat. And
thank you very much, Alessandro. I see there are some questions. They are about units of energy in small and big plants. I think you had a slide where you compared it. Maybe you can open and we can check.
Yes. Yeah. Kilowatt hour. Yes. It is.
Okay. Are there any more questions from audience? Please write them down. In the meantime, I have a question. I wonder how long it typically takes from this baseline analysis to report with the roadmap and all calculations.
Well, in average, I mean, on experience on a dozen of floor projects that I personally followed, we can achieve a very viable result already in 3-4 months of analysis. It can span very much. I mean, the most time demanding part of the project is the first part, so the baseline development, because it has some a very big variability from plant to plant. There are some facilities that have already a very good and structured data collection and documentation, so it's easier for us to analyze, to learn the plant and provide some solution. In other cases, we need to investigate and according to the size of the facility and the amount of parameter that we need to understand, it can take from more or less in the best case scenarios 2-3 weeks to 1 or 2 months of deep dive into the plant to recover the information. Then the part of the creative definition of the solution, feasibility analysis, and plan of the implementation again can be among 4 to 6 weeks, depending on the complexity. So more or less from a couple of months to more, this is the typical duration of this kind of exercise.
Okay, thank you. And then I wonder, is it like proprietary approach and methodology of BTU, or it's kind of published and companies can do it ourselves?
Well, provided that I believe personally on open innovation, the methodology has been published open access on a scientific journal. It was a collaboration with the Polytechnic School of Milano, the university. So the theory and the approach is absolutely open. It's a good tool to have an evolution in industry in general. So everybody can implement this. It is better to work with an engineering company, not specifically VDU, I mean, but it is there is an advantage on exploiting a transversal perspective on the problem. So the advantage that we have is that all the expertise is within our company. So we can analyze the problem from the most broad perspective. So in this aspect, the advantage of having an EPCM company comes from this. Also, working across all the practitioners and in different fields, so chemical industry, pharma industry, and food industry, allows us to see the best practices in different fields. So it may be that in an oil and gas plant, for example, I motivated some methods that are used in GMP areas to allow them to become more formal and more rigorous in the washing steps of their facilities, since we are talking about work package 5, and these allow them to save water and have something more structure in the analysis. So from this perspective, the more experience you gain in this specific field, the more effective will be the result, and also the process of identification of improvement. But as I said, the whole methodology is public. It is this paper here, the Green Value Engineering Methodology, blah blah blah, on sustainability paper journal.
Thank you. Are there any more questions? I see the comment from Andy. Thank you very much. I think he refers to other similar standards.
Yeah, the observation of Andy is absolutely right, because we are we took established methodologies in industry. The know-how is available. The methods have been already deployed, checked, and optimized in field. So we went to the best ones, and the idea of the facilitator is still a necessary aspect, because being democratic in a certain extent, or in other words, being inclusive, involving the highest number of people as possible, this helps to have a good result. On the other side, too many people need to be organized. Otherwise, who does some brainstorming session knows how messy it can become if there is no facilitation in this approach.
Okay, thank you again. And I don't see any more questions, so I would say webinar is closed for now. And if you have questions, of course, you can send it to PHARMECO via PHARMECO page. We will find Alessandro and ask for the answers. And yeah, I see actually one more question. Should we have a standardized pharma checklist so that vendors are familiar with standard approaches?
That's a good question, because in the pharmaceutical field, there are standards everywhere, but very often the more standardization, the less applicable becomes the context. So we are not working with the vendors typically, but we are working in this specific application with the plants and the constraints of each plants that are typically out of any standard. So every facility has their own issues and need to be classified. So the theory or the standards are already available. We have the checklist to have an optimal design, for example, on power centers. That may be a good point, but if the power center have been developed as the cold power unit that we have there, that have been built in years without any good practice, because that was a reactive design against some specific needs time after time. And after a long while, everything was out of spec, let's say. It was much more useful to be able to understand the constraints and the situation. So a non-standardized approach tailored on the specific case, with respect to go with a typical checklist that the electrical engineer comes and say, have you done this, this, this? In that case, the checklist was saying, no, that's awful. But in the idea there, it was instead to find solution in a opposite to the idea of finding what was not working. And so, I mean, the standard checklist valid for all the pharma field and the different possible declination of what is pharma, I see that very, very difficult.
And I guess this answers the next question. Will you share your checklist for pharma?
This is difficult because it belongs to VTU. I need to ask to my boss. That's it.
Okay, so thank you very much again, both for questions and answers and presentation. And we will see you at the next PHARMECO webinar.
Bye. Thank you.
Bye-bye.